day 133. I'm still trying to figure out geometry, mathematical equations with Python. I think we can figure it out. Let's start this geometry off on the right angle. So we'll be talking about lines and angles, and after this we can go and talk about polygons, squares, rectangles, cubes, quadrilaterals, area, perimeters, volume. But let's just start off with just the lines. So going off our previous video in algebra, we learned how to plot lines. So same thing here, we can plot a line and the angle of the slope of the line. We can just go ahead and import numpy as np, import math, and we'll go ahead and use matplot library again, the same as our previous videos. So let's go ahead and start with our plot point. So we got a few different variables we want to talk about. You know, we have the point of the line, the angle, and the length. So we could just add a comment in here. You know, we're gonna plot a line from a point with angles and a length. And we have a few arguments here. You know, our first argument is gonna be our point, and that we'll use a tuple for, and our tuple will use x and y. And this represents our starting coordinates. So x is like the beginning of the line, y is the coordinate of the end of our line. And then the angle, we can use it as a float, and this is like the degree of the angle, like the slope, I guess. And then we got length, which can be the float, which is how long the line is. So let's go ahead and unpack the starting point. So we'll set a variable x, y equals point. All right, so now we can calculate the point using trigonometry. There you go. And y equals, so here's kind of our, here we're calculating the sin and the cosine. And next we're gonna plot the line. So we're gonna plot the figure. So here's from our matplot library. It comes with a function called subplot, and we could pass in an argument here, which is any kind of number that kind of adds an axis. So we can just put in a number like 1, 1, 1. And then we can set a limit. So we can set the limit for the y point, which is our sin angle. And then we can set the axis bounds on the x point. And here we're gonna plot the two lines with the ends. And these ends are referring to our trigonometry equations we used up here. And then we're gonna show our plot. The way that we can use this is now we just pass in our variables. So I can put in any number, like I'll put in 20 for the x, and for y I'll pass in like -40. For angle I could pass in, let's say, 25. And I can set my plot point. And I could put in a length 5, and of course we can adjust this number. So when I hit play, we should see a line. So there's obviously no line running, and I don't see an error output. So let's go ahead. I'm gonna redo this matplot block here, and I'll start with the plot. We could put in an f string label here, and we could do scatter to put the line in and add a color. We can even add a color like green, add a marker to it. So I'll put in like just a O, and then we can add in a label, and we can just copy paste this to make our endpoint. And we can make the color, let's do purple. And for the endpoint, we'll use the end variables that we calculated our radians angle on. Can add a title to it, plotted line, and we can enable a grid. So let's try this out. Here we go. Now we have a plotted line. It shows our angle, our starting point, and our end point. Next, let's talk about shapes and polygons. For this, and here we will use the turtle module. So with turtle, we can do just for scripts, so for underscore in range, pass in whatever we want. So for this, we're doing a 3 points, right? So 3, let's do in range 3, and we could just do turtle dot forward 100 and turtle dot right 120. And once we run this, you'll see what it does. So hit play, and we can see that it basically draws out a little triangle. So if we change this 3 to a 5 and run it again, we can see that it went around 5 times. If we change it to a 2, then we get 1, 2. And if we want to do forward, let's change this to a 5, 500. Hit play, see it goes all the way over there. So it makes the lines way bigger. Turn this back to 100 and change the right to a 200. You can see it changes the angle like drastically. So now it does a 200-degree angle instead of a 120-degree angle. Next, let's talk about polygons and pentagons. So I'm going to grab this matplot library again, and I'm going to grab the polygon from the matplot library.patches. So here we're going to create a pentagon, and we're going to define all of the different vertices. So a pentagon means, penta means 5. So pentagon is a shape with 5 different sides. And the vertices is basically, you know, the first side is going to be 0, 0. The next one, so these are kind of the coordinates that we're mapping out on the matplot graph. And with these vertices, we can pass this in with the polygon creation. So now we're going to create the polygon. So we're going to pass in the vertices and make sure that it's a closed shape. And we are not going to fill it up with any kind of color. So now we're going to plot the polygon onto the graph. So we can create a figure, set the x-axis limitations, and set the y-axis limits. So now if we run the code, we can see matplot brings us our nice looking polygon. So next, let's run through some quadrilaterals, and I'll be using numpy as np for this script. And here I'm going to generate 2D grids for x and y bounds. So we got x1, y1, and we could pass in the numbers we want to give it. So I'll do like 0.6 and 0.07. And then next we can assign y and x to the numpy mgrid. And here we create an equation to set the x and y axis limits. And next we're going to calculate the function values. So I could do like a z with 1. So this line here calculates the value of z based on our given variables, which are x and y. So this fraction here is subtracted from the x, and x is raised to the power of 5, and y is then raised to the power of 3. Then the exponential function is applied, where the exponent is then raised to the power of 2, and the y is also raised to the power of 2. However, the x in this one is a reversed, as it's a negative. So this expression combines polynomial terms and exponential functions. And it shows us the behavior between z, which depends on the values of whatever x and y are. So here we can set a color map and plot quadrilateral mesh. So here we can create a color mesh by using, and our color map is going to be yellow and green. And we'll create a minimum value for our x variable, which is going to equal to the minimum of z. And we'll create our max variable. And the edge colors are going to be the same as face. with just normal flat shading. We'll add a title, quadrilateral. I think I spelled that wrong. There you go, that looks better. Now I can plot the axis coordinates. And now if we run this, P color mesh, there you go. Yeah, so here was the mistake I made. I put min inside the parentheses by accident. So let's get this out of there. So here we can see our quadrilateral in pretty much like a color mesh format. It's like a color map. And if we don't want to use the color map and we just want the regular shape, then we can exit out, delete those. Now let's talk about perimeter and area. So to calculate the perimeter and the area of a rectangle or a square, we don't really need any modules. Just the standard Python library can do it all. As we just need to set a couple variables here. We get the length, we get the width. So for length, I'm gonna add in a float, and we'll run an input command here. And we'll grab the so we'll do area. The area is going to be the length times the width. And the perimeter is going to be 2 times the length time. So it's going to be the length plus the width. And here we can just go ahead and display the results. We'll do f strings here. The area is do area, and we'll put in a float, and we'll put in our second float f string here. And now if I run this script, I can enter the length of the rectangle. I'll put in like 15, and the width is going to be 4. So we can see the area is 60 and the perimeter is 38. So next, let's talk about circles. We could talk about diameter and radius and circumference. So if you want to start with radius, we can do D and R. So that's my little thing that stands for diameter and radius. So here we could do diameter equals 2 times radius. And we'll do return diameter radius. So we can set the radius to whatever we want, let's say 10, and we'll do diameter radius equals and we'll print out these f strings to show our results. So the diameter of the circle equals diameter. And we'll print out our second f string for diameter, radius of the circle. And we can pass in the radius variable we specified up here. And of course, here's where you can set the number. So let's say it's 25, and I hit play. The diameter is 50, and the radius is 25. And if we want to calculate the circumference, we're going to have to import the math module to use the math.py. So let's go ahead and use, I'm going to stick this import up here, and I'm just going to add on to my equation that's already up here. So we already know this is the diameter, And now let's calculate the radius. So the area, calculate the area. And the area is math.pi, so we're going to be using pi, which is 3.14, whatever. And it's going to be pi times radius to the exponent of 2. And the perimeter equals 2 times pi times radius. So now we can return diameter, radius, area, and perimeter. And so all of these are going to be using this function up here. So I'm just going to copy paste this into 2 more f strings. So now we're going to grab the area and the perimeter. These numbers might get a little bit more crazy, so I'm going to go ahead and make these into a float. So now if I run this, we can see the area, the perimeter, the radius, and the diameter. And now what about cylinders? Since we're on the topic about round objects, let's talk about cylinders. So to calculate cylindric areas, we don't actually need any modules for just the basic cylinder stats. So let's go ahead and define our functions here. We can do cylinder volume, which will I'll just shorten it and put in a little note. So I'll call it cyl-vol. Stick to good naming conventions, so I'll just leave the first letter as lowercase. So we're going to define pi. If we do 22 divided by 7, then this will give us roughly the same amount as pi. So we could do return pi times radius to the power of 2 times height. So this equation right here is going to give us the volume of cylinder. And if we want to calculate the surface area, we can do surf area. And for this one, we're going to use the radius and the height again. We'll make a pi equation, and we'll do return 2 times pi times radius times height plus pi times radius to the power of 2 times 2. And this equation here then calculates the surface area of our cylinder. And here down below we can pass in our values. So I can define the radius as, let's say, 13. And the height I could put in as, and here I can print out my 2 f strings. So x of cylinder, blah blah blah, which is going to be x, and radius, height, and they're both going to be floats. And I'm just going to replace this x with volume and this x with surface area, just like so. And now when I hit play, we get the volume of the cylinder and the surface area. Now what about spheres? So we could talk about sphere volumes and cylinders. So actually let's go, these are both pretty similar, so instead of just deleting this all, I'm just going to rename this to sphere. So I'm just replacing these with a sphere instead of a volume. And the only thing I'm going to do here is I'm just going to make a different formula for the returns. So I'm going to do 4 divided by 3 times pi times radius to the power of 3. And this calculates the sphere of the volume of a sphere. And to calculate the sphere surface area, we actually don't need the height for these, my bad. So it's just the radiuses that we need. And to calculate sphere's surface area, it is just 4 times pi times the radius to the power of 2. And we could pass in our radius variable. So the radius value is going to be 10. And now if we run play on this, we can find that the volume of a sphere is this number. Here is the surface area of the sphere. So before ending this video, I want to talk about triangles real quick. So I believe the triangles I'm going to make a separate video on after the Algebra 2 video. So next video is going to be Algebra 2, and the following video after that I'm going to be honing into trigonometry and the Pythagorean theorem. So I'm just going to have one video for all the triangle stuff. So with that being said, I'd like to thank you guys for watching. See you on the next video.